let's look at a free fall problem in physics. What we've got is a tower, and we're going to say that this tower is 15 meters high. And let's say that there is a person standing on the tower and they're going to drop a ball to the ground. Well, we know that if this is a free fall example, the ball will just drop from rest, and so the initial velocity in the y direction is going to be 0. There will be a final velocity, which we don't know. There is a displacement from where the ball has been dropped to the ground. That displacement is a change in y, and we know that that is going to be 15 meters displacement. Let's call the downward direction negative, so that we'll call that negative 15 meters. Another thing that we know is the acceleration of the ball in the y direction is going to be equal to the acceleration due to gravity, or g, and because down is negative, that's going to be negative 9.8 meters per second squared. Well, in this example, the only thing that we don't know, as I've stated so far, is the final velocity. So let's determine what the final velocity of the ball is just as it hits the ground. So what is the final velocity in the y direction of this ball? We reach into our toolkit of kinematic equations, or equations of motion. And among those equations is an equation that does not utilize how long it takes for the ball to hit the ground. It only utilizes the displacement, the acceleration, and it involves the initial and the final velocities. It looks like this. 2 times the acceleration in the y direction times the displacement in y. All of that is equal to the final velocity in the y direction squared minus the the initial velocity in the y direction squared. Well, we know what the initial velocity in the y direction is. That is 0. And we know what the other numbers are, so we can just put our numbers in and solve for our final velocity. And it will go like this. To solve for final velocity, we take the square root of both sides. So the square root of 2 times g, because that's the acceleration in the y direction, times our displacement in the y direction. And now we can put our numbers in. So 2 times negative 9.8 meters per second squared. And we're left with a displacement which is negative 15 meters. Notice that our units under the radical are going to be meters times meters, which is meters squared, divided by seconds squared. So that when I take the square root of this, that'll be the square root of meters squared over seconds squared. And that will give me meters over seconds, which is our unit for velocity. So our velocity, final velocity in the y direction, is going to be equal to, well, it's going to be 2 times 9.8, which is going to be around 19.6, I think, times 15. All right, well, this is going to be somewhere between 300 and 400. Put it into my calculator, and this is what I get. 17 meters per second when I take the square root of all of this. Because we defined down to be negative, this is going to be a negative, so that not only do we have the speed at which the ball has been traveling before it hits the ground, but we also have the direction, and that is velocity. So the final velocity of this ball when it hits the ground was achieved using this analysis. GoPro, stop recording. GoPro, stop recording.